another one is better analytical tools. Because the complexity of our data and the complexity of the relationship between different types of data, we really need new tools to help us better analyze those data and making sense out of the data. Another thing is we need support in systems maintenance and system administration. I think this was mentioned in both the talks of Kathy and Rick. We are facing the problems. Now we have the data and we buy all these hardware to store the data and use and analyze the data. But what if the machine just crashes? Sometimes we have to spend a whole week just to make it back online. So it's a big hassle. Finally, I think we need support in application development and application evaluation. I think it goes hand in hand with the better analytical tools because we could develop many newer algorithms, but those algorithms need to be implemented to be used by different disciplines. So who is going to do that? We need some trained programmers to really develop those software for different applications. So with that, I think you probably already guessed that high-performance computer has been along with my research all through my career. I was really lucky when I was during my PhD and postdoc research, I was supported by centralized facility either in my lab or in a whole institution. So when I came to this campus, I feel myself very lucky to get the support from my dean so that I can purchase a supercomputer of my own. So at that moment, I get to know Dr. Yan Shen, and he happened to have a huge grant, which is much more significant than what I can offer. So we just talked a little bit, and we decided to pool the money together. And we are both very happy about the cluster you're looking at right now, which largely outperforms what I can support by myself. And we get really, really nice support from Gary, who is the head of CIO, because he offered us this really nicely maintained facility at the data center. It's climate controlled. It has staff 24/7. And we had Terry Weil, who was here, and she provided tremendous amount of support. So all of these is really nice, right? What else do I need? So when we were using this cluster, we have a lot of challenges. The challenges are not on the hardware, but more on the software, in terms of the personnel support. So we need personnel support on software maintenance and application. So here, because it's a broader audience, I just want to get some basic idea of why HPC computing needs such tremendous amount of personnel support. First of all, here is the outline structure of a typical HPC system. Here you have the outside network, which connects to individual users, and usually a master node would talk to the outside network and manage all the tasks that's being sent to the cluster. And the master would be the allocating resources to the different jobs, and through the computational network, through the management network, try to set up the jobs on individual computing nodes, whereas the computational network would feed back the results to the central master node. Okay, so now if a user sends a task along, it goes through the outside network and master think a little bit and submit to one node, and it make a record that this node is on use. And when another user was sending another job, the master node, if it works properly, it would send it correctly to an empty node and everything is fine. And now if two users are sending it together to the master would use some queue system and try to manage and still send it to the different places. Okay, it all sounds really nice, right? But that's when the computer works good. So, but it crashes from time to time, and actually when we set up our cluster, within the first month, we had 2 crashes, and one is very significant. We have to shut down the whole class for a couple of days. So, so with that, I think you all get the idea why we really need expertise to help us maintain this nice resource and maybe get it so that it's useful for everybody on the campus. So it's facing, well, I forgot to flash those points, but you can see we are facing different problems with cluster. We need expert support. And finally, I want to end that big data is not just for research. As we hear from everybody today, that it's an integral part of our everyday life. So how can we integrate big data with education? I'm just laying out, here's a course I teach in the spring of 2014. And this course, because at that moment I didn't have much computational resources and I just arrived, I don't feel like I have the energy really to do any hands-on stuff. So the course was designed very theoretical, so I just introduced about biological sciences in general. But when I do the questionnaire to students, one question I asked, would you like to see improvement? Many of my students actually give me feedback that they would really need command line demonstration of the tools. They want to see more hands-on learning opportunities, and show them how to use the software, and they want to have actual practices of using those tools. With that, I want to end my talk, and I thank you for your attention.
Our next speaker is Ryan Omizo. He's an assistant professor from the College of Arts and Sciences and from the Department of Writing and Rhetoric. He's a computational rhetoric person, researcher.
Good afternoon, everyone. My name is Ryan Omizo. I am an assistant professor of the Department of Writing and Rhetoric. So I'm a bit of an outlier, I think, amongst the speakers here. My PhD is in English, and I teach and specialize in writing. My other sort of point of being an outlier is that I don't really have major data needs. However, I do want to sort of frame this talk around this notion of what this high performance computing center might mean for the arts and for the humanities. But first, a little bit about what I do, research, and what I mean by computational rhetoric. So my background here, again, is fairly traditional, PhD in English. My background is in rhetoric, study of rhetoric, professional writing, and the digital humanities. So what I sort of tend to research here, the core, is the motivation, meaning, the persuasiveness of language and communication. I also specialize in sort of genres of workplace writing and other types of professional discourses. And in terms of digital humanities, digital methods that try to transform archiving of texts and also deployment and rethinking the way that we analyze and approach text. Let me skip over that one, don't need that. Now, in terms of the computational approaches, because I'm interested in analysis of text, of meanings, what we try to do, what me and some of my colleagues are trying to do in this sort of new field that we're trying to start of computational rhetoric, is to use approaches from natural language processing, graph theory, machine learning, to be able to process and understand text automatically from a distance, take a macroscopic view so that we don't have to adhere to the normal types of analysis that usually involve sort of what we call close reading, which I'll talk about in a bit. So part of the sort of computational aspect, natural language processing techniques in terms of text cleaning, tokenization, finding collocations, mainly counts, machine learning, SVM classification, other forms of classification, and then graph theory and other network metrics that we try to associate with text and words. Now, part of the research questions that I have, there are two big ones here, is this notion that we have these assumptions about how language works, and we have proceeded for thousands of years about how we think language works, what counts as a sort of commonplace, what counts as a sort of rhetorical device or figure, metaphor, simile, those types of things. But we base these things on assumptions. Someone said something, and we just sort of incorporate it and take it as sort of a canon. What I want to be able to do is to actually test it. Do people actually use language that way? And because of the sort of influx of big data, at least the influx in my field where we're starting to become aware of what we can do and how important it is, we can actually test and validate whether or not these sort of assumptions about how language works actually work in the real world. We also, in particular, I'm sort of working on this project now, we want to make sense and have at our disposal analytics, heuristical devices that we can actually attend to big data, the volume of it, especially the velocity